So let's rock and roll and look at number 5. All right, so looks to me like a lot of just derivative integral rules coming at me. They're just giving me a table with f prime, g prime at specific values. They're telling me that f and g are twice differentiable, right? That means that f and g prime are both continuous. Think of that. The table shown gives values of the functions and their first derivatives at those selected values. Okay, no worries. This is going to be a very rule-based type question. All right, let h be the function defined by f of g of x. Find h prime of 7. So it just wants me to show the work. I welcome these type of questions. So I'm going to find h prime of x first. And that's just using what? Chain, right? Always work inside out on a chain. So g prime of x times f prime of g of x. Get a point probably for doing that. So now let's plug in h prime of 7. And just be careful. G prime of 7 is 8. Times, and I might write another step here, f prime of g of 7, which is 0. Just so that I don't cross my head up a little bit with double plugging there. Then that becomes 8 times f prime of 0 is 3 halves. 24 halves becomes 12. I'm good to go. Let k be a differentiable function such that they're giving me k prime. So is the graph of k concave up or concave down at the point when x is equal to 4? Concavity has to do with the second derivative of k. So when I see this, I can see the product rule, the danger as I call it. And I like to box off my product rule to show me I need to do the product rule on that. So that's k double prime of x equals. So let's do it. I'm going to have to do the chain on the derivative of the first piece of the product for k prime. So chain out f prime of x. What's being plugged in. I'll bring the 2 down. So I'll put this in a parenthesis. And then I'll bring down the 2 and then times f of x to the first. And I won't write it to the first, but I just know it's to the first. But then I got to multiply that by the second part of the product for k prime. Then I'm going to add derivative of the second part of the product for k prime, all times the first part. Now I got to figure out what k double prime of 4 is. Just be careful. F prime of 4 is 3. That's why I use parentheses on this kind of stuff. 2 times f of 4, so f of 4 is 4. That becomes 8. Then I got to multiply that by g of 4, which is negative 3. Just be careful, step by step. G prime of 4 is 2. And then f of 4 is 4, but 4 squared is 16. So when I do that, I get what? Negative 9 times 8 is a negative 72 plus 32, which gives me a negative 40. So it's concave down, right? K double prime is negative, so it's concave down. So let's just write a sentence to answer their question. K is concave down. at x equals 4 because k double prime of 4 is less than 0. You've already shown that value, shown the calculation, you're good to go. All right, now it looks like they have an accumulation, right? They're giving me what m of x is, and they want me to find m of 2. Okay, I can do that. So m of 2 is going to equal, well, 2 cubed is 8 times 5 is 40, plus the integral from 0 to 2 of f prime of t dt. Okay, that's 40 plus, I'm going to put a bracket because the integral of f prime is f. I'm going to use my proper notation and then use FTC from 0 to 2 for, and I'll just write f of t in here or f of x, it doesn't matter. Well, that's equal to 40 bracket f of 2 is 7 minus plugging f of 0. F of 0 is 10. That's a plus here. I apologize on that. So m of 2 is equal to what? 40 minus 3, which is equal to 37. So they're just testing me on using FTC. Is the function m defined in part C increasing, decreasing, or neither at x is equal to 2? So they want me to find m prime. So that's going to be an FTC part 2 for the second part of the right-hand side of m. So the derivative of m will tell me whether or not it's increasing or decreasing or neither. So let's do m prime of x. First term is going to be what? 15x squared. Now this is your understanding of FTC part 2. A derivative of an integral in theory should just cancel out, but remember, order of operations tells us that we have to integrate f prime, plug in x, then subtract plugging in 0, and then come back and take a derivative. So you always should be wary of what the derivatives of the limits of this integral are, but the derivative of 0 is 0, so that's why that'll wipe out, and the derivative of x is 1. So it will cancel itself out, and this becomes plus f prime of x. And again, hopefully you were taught that right, but I know a lot of students struggle with FTC part 2. So plug in m prime of 2. That's 15 times 4, and I might write that out, plus f prime of 2 is negative 8. So that would give me what? 60 minus 8 is 52. So I know that m prime is positive, right, at 2. So that means m is increasing. Use their words. M is increasing at x equals 2 because m prime of 2 is greater than 0. Again, I welcome these type of questions. You just got to be careful. There's always a twist.